So now we're going to find the inverse of a 3 by 3 matrix. So here we have a 3 by 3 matrix A, and the first thing we're going to do is find the determinant of this matrix A. And the way I like to find the determinant is just by copying the first two columns and placing them on the right side of the matrix. So we'll start with this first column right here. I'm going to copy it and place it to the right of the matrix. So notice how I copied the numbers 1, 0, 5 and I placed them to the right side of the matrix. And now I'm going to do the same exact thing with the column 2. I'm going to copy it and place it to the right side of the matrix. Now by copying these two columns, notice how I'm able to create three diagonals. I have one diagonal right here, I have another diagonal right here, and I have another diagonal right here. What we need to do is we need to multiply the numbers in all three diagonals. So that's what I'm going to do right now. In this first diagonal we have 1, 1, and 0, so I'm going to multiply all those numbers together. 1 times 1 is just 1. 1 times 0 is 0. And in the second diagonal we have 2 times 5, which is 10, and 10 times 5, which is 50. And in the third diagonal we have 3 times 0, which is 0. 0 times 6 is also 0. And after we multiply these diagonals, we need to do the exact same thing with the diagonals going the opposite way. So notice how we have three diagonals going the opposite way. We have one right here, we have one right here, and we have one right here. And if we multiply these diagonals together, starting with the first one, we have 5 times 1, which is 5. 5 times 3 is 15. In the second diagonal, we have 6 times 5, which is 30. 30 times 1 is also 30. And in the third diagonal, we have 0 times 0, which is 0. 0 times 2 is also 0. So now, to find the determinant of matrix A, the only thing that we need to do is take the red numbers and add them together, and then subtract them from all the green numbers. So with our red numbers, we have a 0, a positive 50, and another 0. And we need to subtract the red numbers from the green numbers. And the green numbers are positive 15, positive 30, and 0. So the determinant of matrix A is equal to 0 plus 50 plus 0, which is just 50, minus 15 plus 30, which is 45. 50 minus 45 is just equal to 5. So the determinant of matrix A is equal to 5. So after we find our determinant, we have to find what I like to call a new matrix. So let's just call our new matrix N. So how do we know what goes inside of our new matrix N? So let's take a look at our original matrix A. Let's take a look at the number in the top left position, this number 1. If we cross out the row and the column of this number 1, notice how we're left with a 2 by 2 matrix 1, 5, 6, 0. So in the top left position, we need to copy that 2 by 2 matrix and put 1, 5, 6, 0. So now we need to do the same exact thing for every number in the matrix A. So now we'll move on to the top middle number, this number 2. If we cross out the row and the column of this number 2, we're left with a 2 by 2 matrix 0, 5, and 5, 0. So I'm going to copy that 2 by 2 matrix and place it in the top middle position, 0, 5, 5, 0. So now let's do the same thing for the number in the top right position, this number 3. If we cross out the row and the column of the number 3, we're left with a 2 by 2 matrix 0, 1, 5, 6. So I'm going to copy that 2 by 2 matrix in the top right position, 0, 1, 5, 6. So now let's do the same exact thing for the number in the middle left position, this number 0. If we cross out the row and the column of this number 0, we're left with the 2 by 2 matrix 2, 3, 6, 0. So I'm going to copy that 2 by 2 matrix in the middle left position, 2, 3, 6, 0. So now let's do the same exact thing for our middle number, which is 1. I'm going to cross out the row and the column of this number 1. And we're left with the 2 by 2 matrix 1, 3, 5, 0. So I'm going to copy that 2 by 2 matrix in the middle, 1, 3, 5, 0. So now let's do the same thing for the number in the middle right position, this number 5. If we cross out the column and the row of this number 5, we're left with the 2 by 2 matrix 1, 2, 5, 6. So I'm going to copy that 2 by 2 matrix into our middle right position, 1, 2, 5, 6. Now if we do the same thing for the number in the bottom left position, this number 5, if we cross out the column and the row of this number 5, we're left with the 2 by 2 matrix 2, 3, 1, 5. So I'm going to copy that 2 by 2 matrix in the bottom left position, 2, 3, 1, 5. And moving on to the number in the bottom middle position, this number 6, if we cross out the column and the row of this number 6, we're left with a 2 by 2 matrix 1, 3, 0, 5. So I'm going to copy that 2 by 2 matrix in the bottom middle position, 1, 3, 0, 5. And finally, we can move on to our number in the bottom right position, this number 0. If we cross out the column and the row of this number 0, we're left with a 2 by 2 matrix 1, 2, 0, 1. So I'm going to copy that 2 by 2 matrix in the bottom right position, 1, 2, 0, 1. And now we have filled our new 3 by 3 matrix N with a bunch of smaller 2 by 2 matrices. So now we can move on to our next step. Our next step is we need to replace our new matrix N with the determinants of all these 2 by 2 matrices. So we'll start with the matrix in the top left corner. To find the determinants of a 2 by 2 matrix, you just need to multiply this diagonal, and then multiply this diagonal, and then subtract both. So that's what I'm going to do right now. We have 1 times 0, which is 0, and we have 5 times 6, which is 30. 0 minus 30 is equal to negative 30. Now we'll move on to the top middle matrix. We have 0 times 0, which is 0, and 5 times 5, which is 25. 0 minus 25 is negative 25. Now we'll move on to the top right corner. We have 0 times 6, which is 0, and 5 times 1, which is 5. 0 minus 5 is equal to negative 5. Now moving on to the middle left, we have 2 times 0, which is 0, and 3 times 6, which is 18. 0 minus 18 is negative 18. Moving on to the middle matrix, we have 1 times 0, which is 0, 3 times 5, which is 15. 0 minus 15 is negative 15. Moving on to the middle right matrix, we have 1 times 6, which is 6, and 2 times 5, which is 10. 6 minus 10 is equal to negative 4. Moving on to the bottom left matrix, we have 2 times 5, which is equal to 10, and we have 3 times 1, which is 3. 10 minus 3 is equal to positive 7. Moving on to the bottom middle matrix, we have 1 times 5, which is 5, 3 times 0, which is 0. 5 minus 0 is equal to positive 5. And moving on to the bottom right, we have 1 times 1, which is equal to 1, and 2 times 0, which is equal to 0. 1 minus 0 is equal to positive 1. So now we have replaced our matrix N with the determinants of all these 2 by 2 matrices. So moving on to our next step, we need to alternate positive and negative signs in our matrix. So if we start in the top left position, we'll start with a positive sign. Then we got to alternate to a negative, positive, negative, positive, negative, positive, negative, and positive. So now I'm going to scroll down just a bit, just to give myself a little bit more space. So now if we simplify our matrix N, we have a positive and a negative 30. A positive and a negative gives us a negative number. We have a negative 25. Two negatives gives us a positive 25. We have a positive negative 5, so that just stays negative 5. We have a negative 18. Two negatives gives us a positive 18. We have a positive negative 15, so that just stays as a negative 15. We have a negative 4. Two negatives gives us a positive 4. We have a plus 7, so that just stays positive 7. We have a negative 5, so that just stays negative 5. And we have a plus 1, so that just stays positive 1. So now we can move on to our next step. Our next step is we need to reflect all the numbers along this red diagonal, which I'm drawing right now. And if we reflect all the numbers across this red diagonal, all the numbers that are actually laying on that diagonal are going to stay in the same position. So the numbers that are on the diagonal, negative 30, negative 15, and positive 1, they're going to stay in the same position. Negative 30, negative 15, and positive 1. And if we reflect the number 18 and the number 25 along this red diagonal, then they're going to switch places. So this number 18 is going to go where the 25 used to be, and this number 25 is going to go where the number 18 used to be. And if we reflect this number 7 and this number negative 5 across the red diagonal, then they're going to switch places. So the negative 5 is going to go where the positive 7 used to be, and the positive 7 is going to go where the negative 5 used to be. And I think you get the idea by now. If we reflect these numbers across the red diagonal, the negative 5 and the positive 4 are going to switch places. So the positive 4 is going to go where the negative 5 used to be, and the negative 5 is going to go where the positive 4 used to be. So now we have completely found our new matrix N. And the nice thing about this matrix is that it allows us to find the inverse of our matrix A quite easily. So I'm just going to scroll down a little bit just to give myself a little bit more space. So the formula for the inverse of our matrix A is equal to 1 over the determinant of A, all multiplied by this matrix N that we just found. So we know from earlier that the determinant of A was 5. So 1 over the determinant of A is going to be 1 over 5. And we know that our matrix N is equal to negative 30, 18, positive 7. So we have negative 30, 18, positive 7. Then we have 25, negative 15, negative 5. So we have 25, negative 15, negative 5. And we have negative 5, 4, and 1. Negative 5, 4, and 1. And last but not least, this 1 over 5 is a scalar, so we need to multiply this by the entire matrix. So I'm going to scroll down once again just to give myself a little bit more space. The inverse of matrix A is equal to 1 over 5 times negative 30, which is negative 30 over 5, or negative 6. 1 over 5 times 18 is just 18 over 5. 1 over 5 times 7 is equal to 7 over 5. 1 over 5 times 25 is 25 over 5, or just 5. 1 over 5 times negative 15 is negative 15 over 5, or negative 3. 1 over 5 times negative 5 is negative 5 over 5, or just negative 1. 1 over 5 times negative 5 is also negative 1. 1 over 5 times 4 is 4 over 5. And 1 over 5 times 1 is just 1 over 5. So congratulations, now we have found the inverse of matrix A. We probably spent over 10 minutes doing it, which a computer could probably do in less than a second.